Welcome back, guys. It's week two, and we are going to be talking about chapter 5.8, three-wired leveling. So, three-wired leveling is determining distance in a level loop. Let's go over a couple definitions here. So, as implied by its name, three-wire leveling consists of making rod readings on the upper, middle, and lower crosshairs. Formerly, it was mainly used for precise work, but it can be used on projects during ordinary precision. This method had the advantages of proving checks against rod reading blunders, producing greater accuracy because averages of three readings are available, and furnishing stadia measurements of sight lengths to assist balance and foresight distances. In the three-wire leveling procedure, the difference between the upper and middle readings is compared with that between the low, middle, and lower. They must agree with one or two of the smallest units being reported, usually a tenth or two tenths at least count of the rod graduations. Otherwise, the readings are repeated. All right. An average of the three readings is used to compute computational check. And then let's see, the lower in difference, upper in reading multiplied by the instrument stadia interval gives the sight distance. In leveling, the distances are often not important. What is important is the sum of the plus sights is equal to the sum of the minus sights between benchmarks, which minimizes the errors due to curvature and refraction. All right. So we're going to use, there's an example in the book on figure 5.10. That's what we're going to use as an example here in a second. But so let's say we are just looking through the scope or the automatic level, right? What we have is this is our vision. What we have is here, right? This is what we're looking at with the crosshairs. So the other thing that we need to understand is when they're talking about the upper and little, is that there's these little tick marks here and here, right? So this becomes upper. This is the middle. And this is the lower, right? And again, like I said, like I was reading here, we want to check the difference between the upper and middle, and then the middle and lower, right? So we want to take the deltas. I'm just calling this U, right? And then we want to take the middle and lower. I guess I could put it down here. Middle and lower, right? And we want to multiply that by the stadia, right? Stadia. And stadia is a constant of 100. Okay. So again, this is just three-wire leveling in the process of checking distances and checking precise or checking readings. Will we get into a lab? I don't think we have one ready for we won't be doing anything with three-wire leveling level loop lab. But for the course, it's just one of those theories that we need to understand. So in case you ever have to do it in a level loop, you understand the procedure of it. Okay. So again, let's go use. I have an Excel sheet that we can use. And again, Stadia is just the multiplication of your sums or your differences. All right, and then let's go. So let's go through an example here. And so again, I'm going to be using the figure 5.110, and I have this template that's been set up to calculate the backsides and foresights and get the elevation difference. So the other thing that we have is called what we call the C factor, as you can see here. So we're going from benchmark A to benchmark B, and then we have the stadia factor of 100. The C factor if you look at these notes, where is it? There we go. I'm going to zoom into this guy. Is our inclinate our is the C factor is the culmination correction, right? So the C factor is or the formula goes our first setup added by our second setup, the mean of those, sorry, the mean of our first setup and plus the mean of our second setup, subtracted by the length or the distance of our first setup, plus the length of our second setup. All right. And then, oh, I'm sorry. I'm saying it backwards. Sorry. So we're going to take our means first. We're going to go mean of our first setup, mean of our second setup, subtracted by the mean of our four site setup. So these are the back sites, these two. These are the four sites. So it's mean of the back site, mean of the four site, mean of the four site, mean of the four site, right? And then we're just going to add the two back sites subtracted by the mean, the addition or the sum of the four sites, and it's going to be subtracted off. And then we're going to take the backside distances, the two backside distances, add those together. And we're going to take the two foreside distances, add those together, and subtract those. And then we take those results and divide them, and then that becomes our C factor. All right, that was long-winded for me just to give you a very simple formula there. Sorry, guys, not awake yet. All right, so back to this example, so we can go through it. So as we're looking through our deltas or looking through our backside information, I get a backside reading for the top of 0.718, right? And then our middle is 6.33. This is all metric for the example. I know I have it set up in feet, but the example that I'm given is in metric. So we're just going with what we're give for just for the sake of simplicity. We're just going to input the numbers as unitless for now, and then just go off of that. And then we have our blower as 0.550. Okay. Then we'll come over here and input our foresight. And that is, foresight is 1.131. The mean is 1051. That's a comma. That's huge. 1.051. There we go. Our bottom is 0.972. Right. So then that's your two, right? You picked, you got your backside there, you got your foresight, and now you got to pick up and move. Now your backside to turning point 1 is going to be 1.151. And then our middle reading is 1.082. And then our lower reading is 1.013. So as you notice here, I'm getting these little readings here, right? Or I'm getting these results every time I input them. This is where the stadia goes, right? So this is the upper subtracted by the middle, multiplied by our stadia factor, which is 100, and it's giving me 8.50. Yep. And then I'm taking my middle, subtracted by the lower, and then it's again multiplied by the stadia factor, and that's giving me 8.30. And then those two get added together, and that's the distance, right, of that leg from the instrument to the backside. It's a 16.8 meters there. Same thing on the foresight, right? Okay. Upper minus middle minus lower, and again both it's multiplied by the stadia, and I get 15.9, and that is the distance, right? So now let's go to, we got the foresight reading there. Let's go, or sorry, backside reading there. Let's get the foresight reading. And we're going to go 1.401 and then 0.969 and then 0.897. Perfect. And then we get our mean there, right? So this is going to give us means. And then we have also our stadia and the distances. And then that's the summation, right, of the distances. And so what's the total distance now? Or what's the sum of the distance? Well, right now we're going I-20, I-19, which is the foresight, right? Plus our H here, and that's giving us this total sum, right? The total sum of what we've got is 30.6. Same thing on this side for the backside. We go 19, or we go that D6, D26 is going to be our current reading, our current distance, plus the other summation distance of D19, which is 16.8, and it gets 30.6, right? So right now we're currently up to 30.3 on the foresight, 30.6 on the backside. So then we go to our final setup, right? And we're going to benchmark B here. And our reading for our backside is 1.908 for the top. The middle is 1.841. And then our lower reading is 1.774. All right, and again, we have our readings here. And then again, this is the summation here. The sum distance is the E19. So that's our first setup plus our current setup. And that's where we're getting 30.2, right? And then now for our foresight reading, you know, 1.264. Middle reading is 1.194. And then the lower reading ended up being 1.23. Right. And so I have, again, my stadia readings, and I get that distance of that leg, and I get the summation between my first backside and then my last setup site, and that's 30.00. So then once we run through here, this delta, right, being, if we, our elevation of B is 104.1859, we should be able to take this delta, this elevation subtracted by our starting elevation, and that starting elevation, sorry, was, I don't have it written up here. I should have. Oh, let me input it here in the next row. Here, I'm just going to copy this one. It doesn't want to copy it. Oh, there we go. Paste. All right, and let me rewrite this part. So A, oh, caps. And then the elevation of A is 103.8432, right? And so if I take the deltas of those two, well, interesting. Why didn't it give me what I want? Oh, sorry, that's why. Oh, I see. Because this is not whatchamacallit. So I guess let's just do it the other way, the other method. Let's just go equals, and then let's just go by the number 104.1859. Because the other way, what I was doing is taking the whole thing, so that it wasn't recognizing that, you know, as just a number. And actually, I want to go A minus B here on my benchmarks. So I'm going to go 103 here, 0.8432, and then subtract those. So I get negative, and again, let me try to blow that up a little bit more. So right, that my delta, or the delta, is negative 0.3472. And again, if I take the summation between my elevations here, right, of the setups, I have negative 0.4177, 0.1130, 0.6437. I get the same thing of 0. The absolute value, right? It matches, of 3.427. So again, and then we take our means here, backside, the backside of the means, right? And then we take the foreside of the means, add those together, take the delta between the two, and we take the distances of our backsides, add those together, sum those together, take the foreside distances, add those together, take the deltas. Those two results get divided, and we get our C factor, right? Or our collimation error. And again, the collimation error is if you find any type of blunder or issue going on, you can figure that, you can take that value and apply it to a correction, which would be, where are we? C factor blunder. Give me 2 seconds, guys. I just had it and it disappeared. And do another plot here. Oh, okay. So then we would take that value. Oh, perfect. Okay. So then we would take that type of value, our readings, or that collimation error, and we could apply it to our rod readings. So we would apply it to our elevations. So let's say another example would be, so then in this example, go back to video here. So that is all right, to the negative whatever, that becomes -1. Okay. So sorry guys, took too long. I thought I had it and for some reason disappeared. So if we go back here, let me wipe this down one more time. So then the C factor of collimation is, in this case, 0.024.00. And then what does it say over there? So then, in order to, if we had any type of error or any type of issue going on with the collimation, we could apply this to our our data here. Let me move you guys this screen over so I can see everything. So our adjusted delta elevation here. So going off of the summary here, right on the top right corner of the or the top right of the Excel sheet, we would have 30.6, some there, some there, some there. Well, hang on. That doesn't make sense because we would need to get the total distance there. 47. Oh, I see. Now we want to get the sum of these three guys, right? Total length there. So you would take your elevation or adjusted elevation or delta, sorry, delta elevation, not adjusted elevation, delta elevation, which is at 3 point. It would go delta elevation equals R 0.3427. That would be subtracted by our collimation here. It's going to do parentheses halfway, and I realized I didn't need to. 248, 4, 8, not 2 8s. All right, and then we would do the summation of our foresights subtracted by the, or sorry, our summation of our backsights subtracted by the summation of our foresights. So let's see, between the sum of the plus sides of 900. So that would be, let's say, what's that, 30.6. Oh, hang on. Nope. I'm going to go add these first 16.8, 13.8, 13.4. See what that gives me. Okay, now that gives me 44. I'm going to minus that by the foresights, 15.9, 15 point, or 14.4, and 14.1. And that's going to give me 44.4. All right. Now, if I run that, I'm going to go, okay, 44. Subtract those two, and then I get 2.2224. And then I'm going to multiply that by my 0.3247. And I get, I need to adjust everything by 0.033. Okay. And again, it's not much of an adjustment, so you probably wouldn't need to factor that in, especially if you're on relatively flat ground. That wouldn't really be an issue. What would be an issue is if you're on steep terrain. If you're on relatively steep terrain, right, and you're running through your levels and the ground that's something like that, right, and you guys are having to set up here, and then take another measurement here, type of thing, rod readings here, somewhere like that, and it's just a lot of steep ground terrain. You're trying to take level shots through there. That's where you guys would need to put the factors in of the collimation error, or if you're working with 3-wire level leap in the first place and not using a total station or anything like that. So again, this is just the theory behind it. The issue with 3-wire leveling, it's not as accurate as the today's standards, using just electronic distance measurement or even just the automatic levels that we have today. And nothing compared to total stations, right? So this is just another theory of 3-wire leveling, what we used to have to do, or what they did previously to establish distances as they were going to figure out what the length between their sites were, and they can figure that out too. So that is the topic for today. I'll come back next week with some other stuff and some more. Chapter 6, I believe, and then we'll go also cover next week's lab. I think today you guys are starting your profile leveling. Today's the 8th. So today has nothing to do with the lab. It's just, for the rest of the week. But I will be posting homework assignment next week. Be on the lookout for that on Canvas. And then maybe a quiz the following week. So be on the lookout on Canvas too for the homework next week and a quiz the following week. All right, guys. Appreciate you. Thanks for sticking with me on this one. I know it's not fun to do this over online, but again, I am not don't have much time this term to come on through. All right. So, all right, guys, we'll talk later. Thanks. Bye.